Hi students, this is Viswanath, Chemistry faculty for NEET and IIT exams. Last class we completed numericals related to enthalpy of hydration. See the next one. At 25 degrees Celsius, 1 mole of MgSO4 was dissolved in water. The heat evolved was found to be 91.2 kilojoule. 1 mole of MgSO4 7H2O on dissolution gives a solution of the same composition accompanied by an absorption of 13.8 kilojoules. The energy of hydration for the reaction MgSO4 in solid form plus 7H2O gives rise to MgSO4 7H2O is. Okay students, understand the question carefully. 1 mole of MgSO4 dissolved in water, then this much amount of heat energy is released. Next, MgSO4 7H2O is dissolved in water, then this much amount of heat energy is absorbed. Now, enthalpy of hydration we should calculate for this reaction. Say this. In the first case, MgSO4 solid substance dissolved in water. We don't know how many moles of water. That's why let it be n moles. MgSO4 plus NH2O gives rise to MgSO4 NH2O. In this, heat energy released is enthalpy of hydration is minus 91.2 kilojoule per mole. Next, second case. MgSO4 7H2O plus some number of moles n minus 7 H2O gives rise to MgSO4 NH2O. You may get a doubt, how can we write n minus 7 moles of water? Because in the question there is a condition. This compound on dissolution forms a solution having same composition in the first case. So first case, what is the composition? MgSO4 NH2O. So in order to get this same composition, we have to take n minus 7 water molecules in this reaction. Here, this much amount of heat energy is absorbed. Now, this is equation 1, equation 2. By subtracting equation 2 from equation 1, we can get our required answer. Enthalpy of hydration equal to enthalpy of hydration in the first reaction minus enthalpy of hydration in second reaction. So by doing calculation, we can get answer that is minus 105 kilojoule per mole. This is the enthalpy of hydration for this reaction. Okay students, practice all these numericals, then you can do well in exams. See the next one. Enthalpy of dilution. It's very simple. The change of enthalpy when a solution containing 1 mole of a solute is diluted from one concentration to another is called enthalpy of dilution. See this, a solution containing 1 mole of solute, it has a particular concentration. Now its concentration changed to another value by adding solvent, then enthalpy change is called enthalpy of dilution. When a solution is so dilute that further dilution causes no noticeable heat change, the solution is said to be at infinite dilution. Take a dilute solution. To that dilute solution, if we add some more amount of solvent, that means further dilution takes place, then also no heat change is observed. Then we can say that solution is at infinite dilution. Okay, see the numericals. The dissolution of 1 mole of NaOH in 100 moles of water give rise to evolution of heat as minus 42.34 kilojoule. However, if 1 mole of NaOH is dissolved in 1000 moles of water, the heat given out is 42.76 kilojoule. What would be the enthalpy change when 900 moles of H2O are added to a solution containing 1 mole of NaOH in 100 moles of H2O. So see the question carefully. 1 mole of NaOH is dissolved in 100 moles of water. This much amount of heat energy is released. Enthalpy of hydration. 1 mole of NaOH dissolved in 1000 moles of water. This much amount of heat energy is released. Now 900 moles of water is added to a solution containing 1 mole of NaOH in 100 moles of H2O. That means this solution is diluted. That enthalpy change, that is enthalpy of dilution, we should find out. This solution concentration is changed by adding 900 moles of water. Here water is a solvent. Adding solvent means concentration is changed. So in this case we should find out enthalpy of dilution. Let delta H1 for 1 mole of NaOH in 100 moles of water is minus 42.34 kilojoule. Delta H2 for 1 mole of NaOH in 1000 moles of H2O is minus 42.76 kilojoule. Now 900 moles of H2O is added to a solution containing 1 mole of NaOH in 100 moles of H2O. Then delta H equal to delta H2 minus delta H1. Delta H2 this one, delta H1 this. Substitute values, then we can get minus 0.42 joules. So this is the enthalpy of dilution. Now next one, calculate the enthalpy change when infinitely dilute solutions of CaCl2 and Na2CO3 are mixed. Calcium chloride and sodium carbonate are mixed. Delta F H0 standard enthalpy for formation of Ca2 plus ion, CO3 2 minus ion and CaCO3 are minus 129.80, minus 161.65 and minus 288.50 kilocalorie per mole respectively. So calcium ion, carbonate ion, CaCO3 enthalpy standard enthalpy formations are given. We have to find out enthalpy change when these two dilute solutions are mixed. See this, on mixing CaCl2 in aqueous state with Na2CO3 aqueous state, then equation is CaCl2 plus Na2CO3 gives rise to CaCO3 plus 2NaCl. Here two solutions are very dilute and thus 100% dissociation occurs. So in aqueous solution, what are the available ions? Calcium ion, chloride ion, sodium ion, carbonate ion. This calcium ion, carbonate ion combines with one another, each other and form calcium carbonate in solid form, CaCO3 plus 2NaCl plus 2Cl minus, because here NaCl is a strong electrolyte, that's why it can produce ions. Same equation in a simple manner we can write like this: calcium ion in aqueous state plus carbonate ion in aqueous state gives rise to CaCO3 in solid form. Now enthalpy of the reaction equal to sigma of standard enthalpy for formation of the products minus sum of standard enthalpy for formation of reactants. Here product is CaCO3. Reactants are calcium ion and carbonate ion. Their standard enthalpy formation values, if we substitute, we can get our answer. Say this one. This is product, these are reactants. Substitute their standard enthalpy formation values, then we can get our answer, 2.95 kilocalorie. Okay students, practice well. We will meet in the next class.